Good day. Welcome to my blog, which is under the website hlubukani.wixi.com. It's dedicated to grade 12 learners. We'll be looking at the basics of electricity. Specifically, we'll attend to insulators and conductors. We'll contrast the two. We further our lessons by looking at the connection of resistors in series or in parallel. Sit back and enjoy the course. If you look at this illustration here, the yellow line depicts the conductor. That's how we represent it in electrical. And here we've got this item which is in blue. It's called a switch. Now if you look at this point, it's not connected to this end. Now there is a gap. An air gap is an insulator, vacuum is an insulator, and many other cases which you can find in the atmosphere. So if you don't connect two wires, you've got a gap that will become an insulator. It doesn't conduct electrical current. Now, which means that in this illustration as it stands, we have two resistors which are connected to one another. Why two now? If you look at this point, it's not connected to that. So there is no connection between R3 and R2. And if you look at that node, yes, there is a connection between R2 and R4. Now, although R3 is connected to that, but it doesn't complete the circuit because it doesn't go to the other end of your meter, which is the one where is the destination. The intention here is to measure the resistance. So now, these two are connected to one another, but not to the meter at this point. But each end of it is connected to the meter, hence the connection is series. So the meter will be measuring from here, you go around up until there, which now is a series configuration. The total resistance for series, you just add individual resistance. Now the total resistance RT will be R4 plus R2, 100 plus 100, which gives us 200 as illustrated there. How can we remove R4? Now, we can bypass it if we connect these 2 points. Now this is a full conductor. Now the current will have a tendency to go through the conductor and not via the resistor. So it's like you are removing it. Now let's do it. We close our switch. There's a full connection. Now R4 is out of the circuit. You have a direct connection of this meter to R2, left and right, on the top and at the bottom. At the bottom, there's a wire going through, and at the top, there is a wire going through now. The resistance don't count anymore because it's bypassed. Now the resistance will be the value of what is on R2, which is 100 ohm. We reinstate it again, make series to become a sum of 100 and 100. That becomes 200. Now let's remove it again. It's a nice tiling. We've got 100. Now let's put this one in a circuit. Now, if you look at the top part of R2 will be connected to the top part of R3, bottom part of R2 to the bottom part of R3. So we've got the resistors connected together on all terminals. That connection is a parallel. We measure across. Now, the total resistance of a parallel, the inverse total resistance of this combination will be the sum of the reciprocal of the resistance. So 1 over RT is equals to 1 over R1 plus 1 over R3. Mathematically, In this instance where the values are equal, the total resistance will be half, and which is 100. Half of 100 will be 50. Let's see if that will do. It is 49.796, close enough. Now we add 100 in series or with this parallel combination. 100 plus 50, what will we get? 150. How do we add it? We reinstate it by removing the bypass. There it is. It's 150. Now in short, to disable the resistor, we can bypass it with a wire, as the current will go through the wire and leave the resistive part. Now the total resistance of any series combination is the sum of all those resistances, but in parallel the reciprocal of the total is equal to the sum of each individual reciprocal for each resistance. So that's how we work out the total resistance. So as for our lesson today, conductivity, which occur in conductors, and non-conductivity, which occur on insulators such as a gap, and various connections. We will end the lesson right here, and enjoy the rest of the day, and good luck.